For a general equation of SHM, we have seen in the previous session that if a particle is in UCM, then the projection of this UCM on vertical or horizontal diameter is simple harmonic motion. On horizontal or on vertical diameter. Particle goes from A to P in time t. The angle described is theta. Theta equal to omega t because time is t. And we have written equation of SHM either x equal to A cos omega t or y equal to A sin omega t. I have explained all about simple harmonic motion, the preliminary concept. Now, we don't know whether particle will start always from the point A or not. It may or may not start. If the particle starts from some other point, suppose it is not starting from the point, A, but it starts little earlier than the instant when it is at A. Then how to write the equation of SHM? If the particle starts from the point, suppose I, which is little before the instant when it is at A, then equation of motion going to be changed. Similarly, if it starts from I dashed instead of I, then also equation of motion of the particle in SHM going to be changed. It will not remain the same, that is x equal to A sin omega t or y equal to A sin omega. But remember, the angle should be measured from this reference line always, from AO dashed. Okay? So reference circle is there and reference line is also there. If we imagine that the particle starts its motion little earlier than the instant when it is at A and describes an angle theta in time t. Instead of A, it starts from I and makes an angle theta at the center. I mean angular displacement be theta, and that also in time t. In that case, to find the equation of motion, we should remember that the angle we are going to measure from this position. So we need this angle. What about that angle? To know that angle, we need to know this angle, this AOI. So let the particle starts its motion little earlier than the instant when it is at A. And describes an angle theta in time t, where angle AOI, that initial position with respect to this reference line, we have taken epsilon. Okay? Then the actual angle with respect to the initial line going to be theta minus epsilon, this angle. This is going to be theta minus epsilon. So equation of motion of the particle in SHM in this case is going to be what? Y equal to E sine theta minus epsilon. This is nothing but E sine omega t minus epsilon. This epsilon will refer as initial phase angle or epoch. This epsilon will be referred as initial phase angle or epoch. Okay? Similarly, imagine the particle starts little later than the instant when it is at E. Same thing, just it will start from a point like this, I dashed, and describes an angle theta in time t, where this one going to be what? Epsilon, and this one is theta. Okay? So how to write the equation of motion of particle in SHM in this case? Let us do it. Let the particle starts its motion from I dashed, that is little later than the instant when it is at I dashed. Here also we are taking angle AO I dashed equal to epsilon. A is the initial point, that reference line A. Little later than the instant when it is at A, obviously. Okay? And angle AO I dashed equal to epsilon. Let it describes an angle theta in time t. Then y going to be what? We need to measure this angle, no? This one. This total angle is required. Angle AOP is going to be epsilon plus theta. So equation of motion will be the equation of SHM going to be y equal to E sine theta plus epsilon. E sine, here also epsilon is the initial phase angle or epoch. So once we got A sine omega t minus C, this one, now we are getting A sine omega t plus C. So general equation of motion of a particle in SHM can be taken as y equal to A sine omega t plus minus epsilon. Depending on that, you take the plus sign, whether it starts before or it starts after. If you start after, then plus. If you start before, then minus sign will be there. Clear? Hope you have understood. one term I have used frequently here, that is called phase of particle. Initial phase I told you. This term is very important. When you have referred the equation as y equal to a sine theta or omega t, this omega t, phi equal to omega t describes phi equal to omega t. It defines particle position, velocity, acceleration, everything. Okay? This phi equal to omega t is the phase. So in general equation, what is the phase here? For general equation of motion, phi is a function of t. This is given by omega t plus or minus epsilon. Okay, this is called phase. Why? Then how to define? In physics, there must be a definition of this thing, no? Omega t plus epsilon or phi. Phase of a particle, the quantity which tells about particles' position, velocity and acceleration. Particles means which particle? In SHM is known as phase. Okay? Phi equal to this thing is the phase of the particle in SHM. Phi equal to omega t plus minus epsilon. Okay? Why, you will ask me? No need to ask. Like previous one, if we find velocity, what will velocity tell? V particle, again you go by the same way, dy by dt, it will be omega cos omega t plus minus epsilon. This cos you write 1 minus sine square omega t plus minus epsilon, a omega 1 minus y square by a square, same thing. So V particle in general equation of motion also omega root over a square minus a square. Previous lesson we have seen the same expression. And acceleration is what? Acceleration is F equal to minus omega square y. Same relation valid also here. Okay? See one numerical where I am going to explain this general equation of SHM concept, one or two problems. So let us solve this HC Verma sum number 5, page 252 sum. How to do? You compare the equation always. Particle of mass 10 gram oscillates according to this equation. Find the amplitude, the time period and spring constant. No spring is there, they are asking spring constant. The position, the velocity and the acceleration at t equal to 0. Spring is not there, they are asking spring constant. Why? Because this equation might have they got while discussing the motion of spring, vertical or horizontal motion, neglecting gravity. We have seen that. No role of G. So this equation x equal to 2 sine they have taken, so we will compare with sine only. 100t plus pi by 6. This will take 2 by 100. SI system, let us take. Mass is what? 10 by 1000 kg. Okay, we are comfortable with SI unit. So this is 0.01 kg. First part, let us do the amplitude. You compare with x equal to a sine omega t plus epsilon. This epsilon is called epoch or initial phase angle. So here a equal to 0.02 meter. 2 by 100. Done. First part. Time period. If you compare, then if you compare with this, omega going to be 100, epsilon going to be pi by 6. Now omega is what? 2 pi by time period. This is 100. So T equal to 2 pi by 100. Pi by 50. You put pi equal to 3.14, that divided by 50. All keep it this form. No one can remember the answer. No, even I don't remember. So it is pi by 50. Whatever. This is the answer of time period. T equal to 2 pi by omega. Now time period you got. Spring constant we have to find. Now T equal to 2 pi by omega you know. Or T equal to 2 pi root over, remember the relation, m by k or k by m? T equal to 2 pi root over m by k. So, you just compare. T we got pi by 50, 2 pi, mass is 10.01 by k. Pi get cancelled. So 1 by 100 equal to root 0.01 by k, squaring both sides. 10 to the power 4.01 by k. So k is going to be 100 Newton per meter. Okay? Hope you have understood. Now let us find the position, velocity and acceleration at time t equal to 0. This is just mathematical. X equal to, we have 0.02 sine 100t plus pi by 6. So, let us find position. Position after what time? They said that at time t equal to 0. For t equal to 0, x going to be 0.02 sine pi by 6. Sine pi by 6 is 1 by 2. X is 0.01 meter. Velocity how to get? Just differentiate. Differentiate with respect to t. dx by dt is 0.02. What will happen? That coefficient of t will come out. 100, it will be cosine 100t plus pi by 6. And for t equal to 0, zero point 0.02 100 cos pi by 6, 2 into root 3 by 2, root 3 meter per second, that is 1.732. Okay, acceleration how to find? The same expression, that velocity 1, this is for displacement, this is for velocity. Now differentiate this one. Since v equal to 0.02 into 100 cos 100t plus pi by 6, that is 2 cos then find, then differentiate again. F will be dv by dt minus 2 sine 100t plus pi by 6. Wait a minute. This 100 will come out? No. Whenever you differentiate, the coefficient of t will come out. So multiply the result by 100. For t equal to 0, dv by dt f going to be minus 200 sine pi by 6. Okay? Because you just differentiate. This is going to be minus 100 meter per second square. So acceleration is minus 100 meter per second square. And this minus sign for direction only. Now let us calculate energy of a particle in SHM. Energy of a particle in SHM. Motion is involved. This is also linear motion, just to and fro motion. So every quantity as a particle has in uniform motion or motion with acceleration, not uniform motion, motion with acceleration, it also must have. So when the particle is at say arbitrary distance x from the mean position or y, whatever you are accustomed to take, no problem. Then we know the velocity of particle is omega root over a square minus x square. Acceleration is minus omega square x. We are habituated. We have taken this expression already. Now, energy means what kind of energy? Let me tell you, as it has velocity, kinetic energy is there. As its position being changed, so it must have potential energy also. Am I correct? So it has both kinetic and potential energy. Okay? Particle position is changing. So kinetic energy is due to what? It has kinetic energy. It has K.E due to its velocity. And it has kinetic energy due to its velocity. It has potential energy due to its position. So let us write kinetic energy first. Kinetic energy Ek when displacement x. Kinetic energy Ek will be what? Half m v square. Put the value of v. So Ek is half m omega square a square minus x square. Potential energy is what? Potential energy is the amount of work done to change the position of the particle. Okay? So this we remember the definition because already we have done. Potential energy equal to amount of work done to change the position of the particle. Okay, amount of work done to change the position of the particle. How much work is done? How do you calculate work done? Particle already displaced. If no displacement is there, no potential energy is there. So, if you have displaced by x already, to displace it further, you have to do work. And that work done will be stored as potential energy. Clear? So we imagine that the particle displaced slightly by distance dx away from the mean position. Okay, towards right. Against what? Against the force of SHM. That force is what? Acceleration, you know. If the mass of the particle is m, force will be m into f. Agree or not? M minus omega square x. Am I correct? So potential energy we will calculate by giving a small displacement. For small displacement dx, for small displacement dx, work done dw is what? You know it very well. F dot dx. F is what? What's the angle between f and dx? 180 degree. So this will be minus f dx. But f is already minus. So dW for this small displacement is given by m omega square x dx. Now total work done for displacement x is what? Integration m omega square x dx, and that we have taken from 0. At origin you have not displaced, no potential energy. From 0 to this position x you have taken, so it should integrate 0 to x. This is m omega square x square by 2. So potential energy equal to half m omega square x square. EP we got, and EK also we got. By actual calculation we have seen that EK is what? Kinetic energy, that is half m omega square e square minus x square. Let us plot the graph of potential energy and kinetic energy via distance. Okay, let us do it. Both are parabolas, no? First one is very easy. I think you all understand. This is, if we take energy this way, E we are taking this way, and distance x in this manner. Okay? We are plotting potential energy first. Let us plot P versus x. So this part PE is proportional to x square. So this is y equal to kx square type, which is never negative. So potential energy graph will be a parabola. Agree or not? Y equal to kx square. This graph is what? For k greater than 0, it will open upward. So this is parabola. And what is the maximum energy? Maximum potential energy that you get for x equal to A. This part is x equal to A, and this part is also A. For A it is maximum. This energy maximum becomes what? Half m omega square a square. What does it get? At the extreme position. Plotting of this can give you trouble. Kinetic energy. But kinetic energy also parabola. K is proportional to a square minus x square. It is 0 when x equal to plus minus a. And x square has coefficient negative. So this parabola going to open in what direction? It is going to open in downward direction. Agree or not? Because at x equal to a, this is going to be 0, so we take it this manner. This is also parabola opening downward. Okay? Wait a minute. Same graph. This. Okay? This part is A. This part is minus A. Now the thing is that what is the maximum value of kinetic energy and what is the minimum value? K is maximum when x equal to 0. Really it is maximum. For x equal to 0, kinetic energy maximum. What is potential energy over there? Potential energy will be 0. When x equal to a, kinetic energy is 0, but potential energy is maximum. So it's okay. At x equal to 0, K, at x equal to 0, K half m omega square a square, P 0. So total energy is what? Half m omega square a square. Ignore not. Total energy at x equal to 0. Say at x equal to a. When x equal to a, what do you get? Potential energy half m omega square a square. Kinetic energy half m omega square. So what about the total energy? Total energy is here also. Potential at x equal to a. This is 0. X equal to a, no? So kinetic energy 0. Total energy is. So you take it at extreme position or at the mean position. Potential energy, total energy is half m omega square a square. At an arbitrary position, graphically, can you explain what is the total energy? Suppose displacement is x, then this part going to be kinetic energy. Potential energy how much? For x equal to a, this much. This total is going to be potential, and this part kinetic. If you add it at that part, then it is going to be total energy. Every time total energy is going to be half m omega square a square. Graphically. Algebraically, how to get? We have seen that kinetic energy is half m omega square. Potential energy is half m omega square x square. If we add them, total energy is going to be x square get cancelled. Okay. So total energy will remain half m omega square a square. Total energy of a particle in SHM is always constant. Clear? Hope you have understood. So at which position kinetic energy, potential energies are equal, this we are going to find. Let them equal when x equal to a. When displacement is x. When x is the displacement. K equal to P. Now, K is how much for displacement x? Half m omega square, a square minus x square. P is what? Half m omega square x square. So a square is 2x square. X is plus minus a by root 2. It has consequence on the graph paper that this distance is minus a by root 2 from origin and this is a by root 2 from origin, where kinetic energy and potential energy intersect. It means they are equal. So on the graph, location of this point going to be a by root 2. This total distance a, this part is a by root 2. Here also this part a by root 2. Clear? Now I am going to discuss very interesting phenomenon on this energy. Energy method in SHM can help you to solve many problems in simple harmonic motion. What is energy method in SHM? This is very interesting. Before you start solving problems from simple harmonic motion, all the strategies you must know. The first strategy is to prove SHM. How to prove it? Give a small displacement to the particle. Find the restoring force from their acceleration. If acceleration proportional to displacement, motion is SHM. There is another very brilliant and elegant method to solve SHM. How to? This is energy method. Why energy method? Just to prove that total energy of a particle in SHM is equal to a constant. We are going to apply this principle. If they have given that particle obeys this law, from there you prove that motion is SHM, calculate the time period. So if you get the expression for acceleration or force, you so that it is proportional to this. Both force and acceleration both may be proportional to displacement. If you find convenient for acceleration, go for that. Force, go for that, no problem. Because when acceleration is F equal to minus omega square x, force is what? mf. See, both the expressions are proportional to x. Let us take the very first example where, in case of spring, what we have done before for spring, for vertical oscillation or horizontal. Horizontal we have done, let us do it for vertical. For vertical oscillation of a spring. Same expression, same T equal to pi root over m by k. For vertical oscillation of a spring, we are going to prove how the motion is simple harmonic. Okay? Same for horizontal oscillation of spring. This is the spring. Spring is there. And we have attached a particle. Its mass is m. Force constant is k. Okay? So the method is that you give a small displacement. Let the mass m pushed or pulled slightly downward by x and then released so that the mass obtains velocity equal to v. What will be total energy? You have pulled it downward by x. So total energy is how much? Tell. That energy stored in the spring, half kx square, and you said that I will give a velocity v to this when I leave it. So it will be half mv square. Clear? Now, energy of a particle in SHM constant. That information is known. Let total energy be constant. Half kx square, half mv square equal to a constant. This implies kx square mv square equal to a constant. Differentiating with respect to t. K into, what is derivative of x square? 2x you know, but we have differentiated with respect to t. So there will be dx by dt. Okay? Plus m into, what is derivative of v square? 2v dv by dt. This is 0. Therefore, kx, v stands for what? You know, dx by dt. So you put minus v over there plus 2mv, v over there 2mv dv by dt. That is 0. Therefore, 2mv dv by dt minus 2k vx. Vv getting cancelled, 2 getting cancelled. So dv by dt is what? Minus 2 get cancelled, not k. Don't cancel k. 2 only. Minus k by m into x. What have you got? By assuming energy constant, what have you got? This is acceleration. So F equal to minus k by m into x. Since A proportional to x, therefore motion is SHM. And how do we get the time period? Now F equal to minus omega square x k by m root k by m T equal to 2 pi by omega 2 pi root over m by k. See, this energy method is also a very simple method to prove SHM and to calculate the time period, isn't it? In the second problem on energy method, it's a brilliant problem which you can solve easy for your understanding by using energy method. How to? Again the same principle, pull the mass slightly by x downward and then leave it so that it obtains a velocity v. Okay, you understand? You have to calculate, find time period here, where the pulley whose moment of inertia I, a mass m is attached and a spring is there which is not loosely bound, tightly. So you have to find the time period. How to? If you don't disturb, you won't get time period. You don't get restoring force. So you have to disturb the particle. Let the mass m be pulled downward slightly by x and then released. So that it obtains velocity v upward. Again my energy method, total energy of the system is what? Here it is half k x square spring for the mass half mv square. Pulley has moment of inertia, so it has rotational kinetic energy. Remember it, half I omega square is a rotational kinetic energy. But how to get omega here? And velocity how to relate? Because angular velocity omega, isn't it? Angular velocity omega means linear velocity v equal to r omega, where r is the radius of the pulley. You assume that r equal to radius of the pulley. So that if required you can write I equal to cylindrical, I equal to what? Half m r square. If required we will do it. Now this is half kx square, half mv square, half I, omega is what? V by r whole square. Radius of the pulley we will take. If required we will keep it that form only. So this will be half kx square half m plus I by r square v square. Okay, assume that total energy constant. Let half kx square plus half m plus I by r square v square equal to a constant. What does this imply? Kx square I by r square into v square equal to a constant. Okay. Now differentiating with respect to t, 2x dx by dt m plus I by r square 2v dv by dt equal to 0. So 2kxv plus m plus I by r square into 2v dv by dt. So v getting cancelled. dv by dt going to be what? m plus I by r square, this by k into x. dv by dt stands for what? This one stands for acceleration. Since a proportional to x, therefore motion is SHM. How does it help? You just compare it with f is what? Minus omega square x. So omega is under root two pi root over k by this problem. You can try with force method. You can try with force method, but this is better method to solve the sum by using energy method. Hope you have understood what is energy method of particle in SHM. This helps us to get the time period nicely. Okay.